Hello, class ninth. How are you all? So, we have been studying about the motion. Yes, chapter number 8. So, last time we studied distance time graph of uniform motion and non uniform motion. Yes, do you remember? And we also had gone through different equation of motion that we get from the graphical method. Well, we will study about it. And we also studied what is velocity, what is acceleration, what is the definition of velocity, what is the definition of acceleration. Yes, today we will study the velocity time graph. Yes, today we will study the velocity time graph. As you can see on the screen, the graph, velocity time graph. So, but before we study the velocity time graph, let's revise whatever we studied in previous class. Okay, let's revise whatever we studied in previous class. So, kids, we studied about the velocity, average velocity. Yes. So, what is velocity? Velocity of a body is the displacement of the body per unit time. Yes, the displacement of the body per unit time. And the formula for the velocity is displacement upon time. Yes, and since the velocity has both magnitude and direction, that's why it is a vector quantity. Okay, and if we talk about average velocity, what is average velocity? Average velocity is the ratio of the total displacement upon total time taken. So we can also say average velocity means average velocity also means that if the average velocity is also the mean of the initial velocity and the final velocity divided by 2. So we can say average velocity is equal to initial velocity plus final velocity upon 2. Means if the initial velocity is u and final velocity is u, then final velocity is v, then u plus v upon 2. That will be average velocity. And if we talk about the unit, speed and velocity have the same units. Yes, speed and velocity have the same unit, meter per second. Yes, it's very easy. And we also studied about the acceleration. Yes, acceleration is actually the rate of change of velocity. Yes, acceleration is rate of change of velocity, or you can say acceleration is the change of velocity of body per unit time. Yes, so the formula for the acceleration is equal to change in velocity upon time. Acceleration is equal to change in velocity upon time. Or if the velocity of body changes from initial value u to final value v, then the acceleration will be a is equal to v minus u upon t. A is equal to v minus u upon t. And if we talk about the SI unit of acceleration is meter per second square. Yes, or you can say meter second square inverse. And you know that there are two type of acceleration: uniform acceleration and non-uniform acceleration. Yes, so what is uniform acceleration? Uniform acceleration is the acceleration if the change in velocity is equal to in equal interval of time, it is uniform acceleration. If the change in velocity is unequal in equal interval of time, then it is non-uniform acceleration. And we studied about the distance time graph for uniform motion and non-uniform motion. Yes, we also studied about it. So you know that distance time graph for uniform motion is always a straight line graph or linear graph. This is because in uniform speed a body travels equal distance in equal interval of time. Okay, so the formula for uniform motion distance time graph will be v is equal to s2 minus s1 upon t2 minus t1. Okay, where s1 s2 is distance, t2 t1 is time in second. And if we talk about the non-uniform motion graph, the non-uniform motion graph is non-linear. So the distance time graph for the non-uniform motion is non-linear, and this is because non-uniform speed a body travels in equal interval of time. Yes. And we also studied the equation of motion. Yes, there are three equation of motion. First is v is equal to u plus at. Second is s is equal to ut plus half at square. Yes. And third is 2as is equal to v square minus u square. Okay. So v is the final velocity, a is acceleration, t is time, s is distance traveled, and u is initial velocity. Okay. So kids, as you can see on your screen, this is the velocity time graph. Yes, velocity time graph, as you can see. So kids, on x-axis time is shown in second, and on y-axis velocity is shown. Okay. So the change in the velocity of a body with time can be represented on velocity time graph. Yes, the change in velocity of the body with time. Yes. Okay. And in this graph, in this graph, velocity is taken on y-axis, and time is taken on an x-axis. Okay. Suppose a body is moving with uniform velocity. Yes. First of all, we will see the diagram and formula for the uniform velocity graph. Okay. So this is the uniform velocity graph. Then we will study in next slide about non-uniform velocity graph. So suppose if the velocity is uniform means speed is constant but direction is given. Okay. If a body moves with uniform velocity, then graph will be straight line. Yes, then the graph will be straight line because speed is constant. That's why graph is straight line, because speed is constant. Okay. So the graph will be a straight line parallel to x-axis. Yes, the graph will be straight line but parallel to x-axis. Okay. And this is because the velocity does not change with time. Yes, velocity is not changing with time. Time is changing, but speed is constant. Okay. So as you can see in the picture, suppose after 5 seconds, the velocity of a car is 20 kilometer per hour. Okay, suppose the velocity of car is 20 kilometer per hour, and after 10 seconds means 15, 5 plus 10, 15. So after 15 seconds, the velocity of car is still same, 20 kilometer per hour. Means the speed is constant. Yes, velocity is not changing. So as you can see, the A point and B point, which are actually if we cross a line, then they will go straight. So we can say that for uniform velocity means if the speed is not changing, then for uniform motion the graph will be a straight line graph. Yes. So thus we get a B C D, the frame for the time frame. So we can easily calculate to determine the distance traveled by the body between the point A and B with velocity 20 kilometer. How can we determine if we know the distance traveled by the body between A and B point with the velocity is 20 kilometer per hour? We can easily calculate, because you know that formula of velocity is v is equal to s upon t, because we are studying about velocity. The formula for velocity is v is equal to s upon t. Yes, means displacement upon time. So s will be equal to v into t. So we know that value of v is given 20 kilometer per hour, which is actually equal to AC. AC is equal to 20 kilometer. AC is parallel to BD, so both will be equal, AC or BD. And here time will be between time will be T2 minus T1, which is actually DC, which is equal to AB. Okay. So time is T2 minus T1. So we will put in the place of V, we will write AC. In the place of T, we will write T2 minus T1, and T2 minus T1 is equal to CD. So the S is equal to SC into CD. So the area of ABCD, thus we get S is equal to area of rectangle ABCD will be AC into CD. In this way we can get. So V is equal to S upon T, and the value of S is V into T. Okay. So S will be equal to area of rectangle ABCD. Okay. So it's easy. I think you can easily calculate it. It's not difficult. Okay. Now let's see the next diagram, next graph. Let's move on the next point. So kids, now you know that if the for the velocity time graph, if the velocity is constant, means in uniform motion, then we can say that the graph will be straight line graph, means the line will be parallel to x-axis. And if a body whose velocity is increasing, means with time, yes, velocity is increasing, means speed is changing, yes, then the graph will be what? Then the graph will be what? So if the speed is changing, then it will be a non-uniform motion graph, yes. But the velocity is changing. When the velocity change, then acceleration produce. And this graph is for uniform acceleration graph. This graph is for uniform acceleration graph. So if a body whose velocity is increasing with time, if velocity is increasing, means velocity is changing, and velocity change, acceleration produce. So if a body whose velocity is increasing with time, then the graph is a straight line graph. Yes, the graph will be straight line graph, because the value is equal in equal time. Yes, the velocity is equal in equal interval of time. That's why. But the value, this is because the value increases by equal amount. Yes, this is because the value increases by equal amount with the equal interval of times. Yes. So remember kids, this is the graph for uniform acceleration, or you can say non-uniform velocity. So when the speed is changing, then value acceleration will produce, definitely produce. So for this, the graph will be straight line graph. Okay. So as you can see, the area under velocity and time graph is the distance, magnitude, displacement of the body. So just imagine that on x-axis we have shown time, and on y-axis we have shown velocity. So after 10 seconds, imagine after 10 seconds, the velocity is 10 kilometer. Yes. Now the velocity increase, and after 20 seconds the velocity of the car is 20 meter per second. Then after again 10 seconds, means after 30 seconds, the velocity again increased by 10. So the velocity is now 30. So the increase of 10 is increasing. So the graph, if we will draw the line, straight line graph, then it will be straight line graph. Okay. So if we draw the line, we will get the graph, as you can see, and we can make some point like D point, C point. So the frame here will be between T1 and T2, and we got here two diagram. So the area under the velocity time graph is the distance of the body. Yes, the area under velocity time graph is actually the distance of the body. So the distance traveled by a body between point A and E, is the area and A B C D E under the velocity time graph. So here is S will be equal to the area of ABCD. Yes, because the area under the velocity time graph is actually the distance of the body. Yes, area under velocity time graph is actually the distance of the body. So that's why S is equal to AB, area is equal to ABCD. We can divide this area into two parts. Area of rectangle plus area of triangle. So here rectangle is ABCD and triangle is ADE. So ABCDE, for rectangle we know length into breadth. So here length is AB, or you can say DC, and breadth is BC, or width you can say BC. BC is equal to AD, AB is equal to DC. So for area of rectangle ABCD, S is equal to AB into BC, and for area of triangle ADE, 1 upon 2 into base into height, so AD into DE. So this will be the formula for area of this uniform acceleration graph. Yes, when the velocity is increasing. Okay, so S is equal to AB into BC is equal to plus 1 upon T AD into A. So it was all about, you will have to draw the diagram. The diagram will come in exam. Okay, because you have not so much biology chapter, you have most of the chapter of physics, so you will have to study, because most of the question will come from them, and from this chapter, especially from chapter number 8 and chapter number 9. Chapter number 8 and from chapter number 9, numerical will come. Numerical will come. Yes, if you will not learn if this chapter properly, if you will not solve the question, the marks will be cut. The marks will be cut. Yes, around 20 marks you will lose in exam. Okay, so you will have to learn. You will have to learn these diagrams. I hope you understood. Now let's move on the next point. Okay, so now let's see two more graph. So we saw the graph for uniform acceleration. Now we will see the graph for non-uniform acceleration. But before it, we will also see the graph for uniform deceleration. Yes. So in previous slide, the graph was for uniform acceleration. Now we will see the graph for uniform deceleration. What is the difference between uniform acceleration and uniform deceleration? Uniform acceleration means velocity increasing. Uniform deceleration means velocity is decreasing. So, if a body velocity decrease with time, then graph will also be straight line, but in a decreasing slope. And in previous slide, we saw the graph for uniform acceleration in which velocity was increasing, so the graph was straight line but with increasing slope. But here, as you can see the first picture, can you see the first picture? And the graph is deceleration. Yes, this is because the velocity is decreases by equal amount with equal interval of time. Yes, so as you can see in the picture, time is shown on x-axis and velocity is represented on y-axis. So suppose the value in the beginning of the car is you started suddenly the car, and the value of the speed velocity is 30 meter per second. After 5 seconds you slowly decrease the speed using the accelerator, so the value becomes 20 meter per second after 5 seconds. Then after 5 seconds again it decrease, then after 5 seconds, after 15 seconds, then the value will become 10 meter per second, and at last after 5 seconds the car come at the rest. The car comes at the rest. So this is uniform deaccelerated graph. Yes, means velocity is continuously decreasing and decreasing and decreasing, and at last it comes to zero. So the graph, as you can see, the slope is downside. Yes, just like downstairs. Okay, I hope You understood this graph. You understood this graph. This is very easy graph. Now look the second graph. Look the second graph. This is also the graph for velocity and time. Here also time is shown on x-axis and velocity is on y-axis. Yes. So if a body whose velocity is decreasing with time, if a body whose velocity is decreasing with time, then the graph will be straight line having decreasing slope. This is because the velocity decrease. But if we see the second picture, if we see the second picture in which you can see the velocity is non-uniform. As you can see in the second picture, velocity is not uniform, means sometime velocity is decreasing, sometime velocity is increasing. So it is showing the different value variation. So it is the graph for non-uniform acceleration. Yes, this graph is for non-uniform acceleration because velocity is changing again and again. Sometime very it goes up, sometimes it goes down. So velocity is changing. So if a body whose velocity is non-uniform, the graph shows different variations. This is because the velocity changes by unequal amount in equal interval of time. As you can see in the picture, suppose your car is at rest, then you start the car, your velocity increase up to 10, then after 5 seconds it goes more than 20, then after 10 seconds, means again after 5 seconds, uh, the velocity decrease and it comes to the 15 the velocity come to the velocity come to the 15 meter per second after 10 second, and again after 5 second 4 5 second you increase and it goes more than 20, then again you decrease and it comes to the 15, means the equal time interval you can see, but the unequal velocity is here. So the unequal velocity means velocity is changing again and again. So it is velocity, when the velocity change, acceleration is produced. So this is the graph for non-uniform acceleration. Yes. So I hope you understood. Okay. It's very easy. It's not difficult. Okay. Now let's move on the next point. Okay, as you can see the displacement time graph. Yes, this is the displacement type graph. This is the graph actually when the body is at rest. Yes, when the body is at rest. When the body is at rest, that time the slope will be parallel to x-axis, parallel to timeline. Yes, when the body is at rest, that time the graph will be parallel to x-axis. But if the body is moving with uniform motion speed, but if the body is moving with uniform speed, in that condition, if the body is moving with the uniform speed, that time the graph will be the same graph just like the distance time graph. Yes, if the body is moving with same speed, uniform speed, that time the graph will be the same graph just like the graph of distance time graph. That distance time graph was actually in a straight line. Yes, so the graph will be also a straight line graph if the speed is uniform. But here if the body is at rest, if the body is not moving, in that condition how will you make graph? So in that condition, to make graph you will have to draw a graph in which time will be on x-axis, displacement means s will be on y-axis, and you will draw a parallel line just parallel to the x-axis. So this will be the graph. Okay, now let me show you again the equation of motion. Okay, if you have not written the previous class, if you don't see clearly, then now I am again showing you. Let's move on the next point. Okay, so equation of motion by graphical method. Okay, so as you can see, these are the equation. The motion of a body moving with uniform acceleration. If a body is moving with uniform acceleration, then can be described with three equation. Yes, if any body, a body means any car, not human body. Yes, we are not just talking here. Body means not a human body. Here means object, any object, motion who can do motion. So if the motion of any object with uniform acceleration can be described with three equation, which are known as equation of motion. Okay, so the equation are, as you can see on the screen. First equation is v is equal to u plus at. Second is s is equal to ut plus half at square. Third is equal to 2as, which is equal to v square minus u square. Fourth is, there is no fourth equation. Yes, there are only three equations. So which are the three equations? Yes, v is equal to u plus at. Yes, and s is equal to ut plus half at square. 2s is equal to v square minus u square. And where u means initial, u is the initial velocity, v is the final velocity, a is acceleration, t is the time, and s is the distance travel. Isn't it easy? Yes, it's very easy. Now let's move on to the next point. Okay, it's time to ask question from you. Question number 1. Draw the graph for if a body moves with uniform velocity. Yes, then how will be the graph? If a body moves with a uniform velocity, then the graph will be a straight line graph. Yes, the graph will be a straight line graph which will be parallel to the x-axis. Yes, and this is because the velocity does not change with time. Yes, why will be the graph straight line graph? If a body moves with a uniform velocity, then the graph will be a straight line graph because the velocity is not changing. Yes, velocity is constant. That's why it is uniform velocity graph. The first graph that I showed you, it was velocity time graph. The first graph that I showed you in first slide. In first slide, the graph that I showed you, it was velocity time graph. Okay, so you know that I have shown you in that graph the time at 5 seconds the velocity was 20 kilometer per hour, and after 15 seconds the velocity was still 20 kilometer per hour. So velocity was same. That's why when we meet A and B point, then a straight line will form through the 20 kilometer per hour. So we know that formula of V is equal to S upon T. So we can calculate S is equal to V upon T because we know the value of V. Yes, and here the time T will be T2 minus T1. So you can also write S is equal to V into T2 minus T1. And next question. If a body is at rest, yes, if a body is rest for displacement time graph, if a body is rest, that time the slope of the graph will be parallel to the timeline. Yes, means this graph will also be a straight line graph. Yes. So when a body is at rest, that time the slope will be parallel to timeline or parallel to x-axis. Okay, so the graph is so easy. Okay, next is write the equation of motion. You already know which are the equation of motion. Yes, first equation of motion is v is equal to u plus at. Second is s is equal to ut plus half at square. Third is 2as is equal to v square minus u square, where u means initial velocity, v for final velocity, a for acceleration, t for time, and s for distance traveled. Okay, question number 3. How will be the graph for non-uniform acceleration and uniform deceleration motion? Yes, how will be the graph for uniform acceleration and non-uniform deceleration motion? So, if a body whose velocity is decreasing with time, the graph is straight line. Yes, Means if we the graph for uniform deceleration motion, the graph for uniform deceleration will be a straight line graph but in decreasing slope. So if a body whose velocity is decreasing with time, the graph is a straight line having a decreasing slope. This is because the velocity decreases by equal amount with equal intervals of time. And if we talk for the non-uniform acceleration, means velocity is sometime increasing, sometime decreasing, then what? If a body whose velocity is non-uniform, means for non-uniform acceleration, when the velocity is non-uniform, acceleration produces. So if a body whose velocity is non-uniform, the graph shows the different variation. Yes, the graph shows different variation. This is because the velocity changes by unequal amount in equal interval of time. So there are two graphs. First graph is for uniform deceleration motion. For uniform deceleration motion, the graph will be straight line having decreasing slope. Why? This is because the velocity decreases by equal amount with equal interval of time. And second is non-uniform acceleration. For this, the graph shows different variation. Why? This is because velocity changes by unequal amount in equal interval of time. I hope you understood. Now we will meet in next class. We will finish the chapter in next class. Okay, we will finish the chapter in next class. Till then.